Hello again, everybody. Problem with your AC not blowing any cold air. We've all been there, right? First, we have to determine, is it electrical, is it mechanical? First thing is, besides looking if the clutch is engaged, there's another thing that you can do. If the clutch is engaged, fine. You know that everything is working. This GM's work on something a little different. Now, there's a couple of things involved. First of all, obviously we don't have cold air. We see the passenger doesn't have, the driver doesn't have, however you put the vents, we don't have cold air coming out to them. But when this is the selector switch. You know that switch where you choose either vents or AC normal or maximum AC or off. Also, there is a selection for defrost, for the defroster, which goes to the front windshield. For that, the compressor also comes on. And blend, which means also defroster and also through the vents. You're going to get cold air. Now, other thing is, if I don't get AC, the first thing I do is I'm going to put the switch to defrost. I want to see at least on the front windshield getting cold air. If they're not, that means I pretty much have an AC problem. If I'm getting cold air in the defroster, right, that means the system is working. However, I'm not getting anything in the other selections. Now, could be a couple of things. Maybe the switch is stuck on defrost and it's not going to the vents to the passenger or the driver. There's another thing called over here, as you see in this one, called, if you can see it, this is the blend door actuator, mode actuator. This is a potentiometer, 12 volts, 5 volts, 0 volts that you turn, and this pot is on the panel where you see the red and the blue, where you control the heat. In other words, blue would be for cold, red is for hot. This is what you're looking at, a potentiometer going to a motor which opens the doors and the flaps. So it will open the doors for the driver and the passenger, and will open the doors, the flaps, for the windshield. That can make it stuck in one position, in the defrost position. And usually when you turn it, you hear a sound. Therefore, first thing is I want to see if I have any AC coming out, even in the defrost. If I do, that means compressor is working, everything is working, but we're stuck in the defrost position and we cannot get it to maximum AC. Why? Because it could be possibility that maybe there's a problem with this air temperature actuator, which is a motor. Or this one over here, the pot. Now, that's to control the airflow. The cold air, where it comes from the air conditioner, obviously. The heat or the cold comes from this, the temperature actuator, right? You're either going to have it from the heater core, or you're going to have it from the evaporator, or you're going to have it going to the vents. That's the airflow is this. The cold air has to come from here. Obviously, the heat has to come from the coolant and the heater hoses and the heater core. So that's the first thing that I do. So let's say I put it in defrost. I don't have even cold air in that. Let's look at key components. We know there's a clutch that has to be engaged. We know that. We know there's a relay. But to make it even more complex, you guessed it, I'll computer again. Everything is computerized, like I tell people. Now, if you look at this, any position that's over here, maximum AC, this one, see the lines? I mean, there's a connection when you flip this. This one, blend or defrost, any of these positions or bi-level should go engage the compressor. But a few things have to happen. There's something called high pressure switch. Now, when you measure the pressure, low on the low pressure side, the high pressure side. Let's say on a good working one, you should have maybe 25 psi in the low and about 250 on the high. About a ratio of 10 to 1 usually I look at. There are protection switches. Protection switches meaning we don't want the pressure to be too high. What do I mean by high? Well, for GM, let's say it will be 450 psi on the high pressure side. We have a protection that opens up, a switch opens up like a fuse to protect the components. Let's say the pressure is too low. Instead of 25 psi, 35 psi, let's say we have 5 psi. That's too low. That's also not good. We have a protection called the low pressure switch. Now again, these numbers are with GM. They could differ from other makes and models, but for GM, roughly these are these. You don't want to go too low. You don't want to go too high. Okay? So, the protection will protect us against the high pressure. The protection will protect us against the low pressure, like a fuse here and a fuse here. To make things more complicated, the computer is involved. The computer gets involved. When I put the switch, I flip the switch. Hey, it's hot as anything in here in this car, right? The first thing, bringing the passenger, put on the air conditioner, right? Guess what we're doing? We're not just turning the selector. We're communicating to the computer. We're telling the computer we need the air conditioning on. It's blazing hot in here. AC request signal. We're sending an AC request signal to the computer. How technical is this now? This computer has to get the request, and that request comes on two conditions: that the selector is in the AC or defroster or blend, whatever, and AC high pressure switch is closed, activated. What does it mean when it's closed? That means the high pressure is in the correct level. Could be 250, 300, whatever it is. If this is open, this will not get a request signal because the pressure is too high. The computer will not get a request signal. But let's say that everything is okay, high pressure side is okay, and again, before you start, you can always measure the static pressure without the compressor on, to see if it's balanced. You should get a balance on the low end and the high end, 75, 80, whatever. They should be balanced. So you have some pressure. Doesn't mean you have a refrigerant, but you have some pressure. Now it's going to close, and now it sends a request, a command. You're with a passenger. The passenger says, again, open up that air conditioning. It's an AC request signal. AC request signal says, okay, not so fast. What do we need? We need the AC low pressure switch to also be closed. That means when this is closed, that means the pressure is not too low. It's in the border of this. So in other words, these are not tripped. This didn't trip, like a circuit breaker. This didn't trip. That's good. The computer says, fine. That's great. High pressure is good. It's safe. Low pressure is also safe because this switch is closed, the protection switch. What happens? Computer says, okay, those protection devices are closed. That means the pressure is correct. That means now I can activate the clutch. How do I do that? A relay, you guessed it. Always a relay. This is 12 volts through a fuse. You go over here, current flows. Now, if there's 12 volts over here, what do we need on the other side that we've been talking about? A ground. Who gives this a ground? The computer gives it a ground. When does it give it a ground? On the conditions that the low pressure switch is closed and it's safe to do so. And the high pressure switch is closed and it's safe to do so. And I get a request from the driver or the passenger or whatever. Then I will ground this. What happens when I ground it? I just activated this part of the relay. See this dotted line? That means this will flip. This switch, which is 10 amps, will be in this direction. Follow the orange. And what do you think will happen? AC compressor clutch. 12 volts here. See 12 volts on that side of the clutch. And 0 volts. Why? Because it goes to ground. So, how difficult, huh? Computer is involved in everything, like we just been going. In fuel pumps, in starter circuits, in AC, in your light switch. That's what I tell people. Don't overrule a computer problem. These are computerized fuel injection cars. Now, if you understand this, let's go to the next level of troubleshooting. Now, I think there's a misconception in troubleshooting AC. Like I said, first thing is no cold air. I'm going to put on defroster. I want to see even if defroster has it. Defroster doesn't have it. That means the compressor clutch is not engaged. Or there's a computer problem. Or a low pressure switch, instead of being closed, is open. Or a high pressure switch is in the other position, open switch, not allowing this. Right? It might be a computer problem. Or this was not grounded by the computer. Or the relay is not activated. Not just the clutch. And not just the compressor. How do you go about it? How do you go about it? There is a misconception, like I was saying, to go and say, you know what? Let me go and jump the low pressure switch. That's the first thing people tell me. And you know what? These are protection safety switches, and there's a reason for them. The reason is to protect the components, expensive components. Compressors, receiver dryers, accumulators, or if everything, there's a protection switch. This is like a fuse. Would you go and jump a fuse and say, let me see if the relay is working by jumping the fuse? No. This is a protection device. There's a reason why it's there. It's to protect the relay, to protect the clutch, to protect components from going bad. Therefore, I do not jump low pressure switches. I do not jump AC pressure. I do high pressure. These are protective safety devices. What do? I measure voltages, and this is what I do. Now, think along troubleshooting. If you're telling me that the computer has to get a request from the person, then he looks at the low pressure. If those two are good, and this one is closed, then he'll send a signal to the relay to the clutch. So you know what? Where I'm going to go? I'm going to go right here. This is my point of attack right here. I'm going to go to the other side of the relay. 12 volts here. If this is grounded at 0 volts, that means, you know what that means? That means the low pressure switch is good. That means the high pressure switch is good. That means the AC received a request signal, a command. And that means that the low pressure switch is activated and the pressure is correct. It's safe to do so. And therefore, it gave me a ground. By measuring this, 0 volts, that tells me all of this is working in one shot. Now you're going to go, how am I going to measure a relay? Well, that's what I wanted to make videos on. A way to measure the relay with the relay in it. If you take out the relay, I disagree with people totally when they take out relays and then measure the terminal 12 volts here with the power probe. Nonsense. Nonsense. You leave the components there. If I measure 0 volts here, that means this has been activated by the computer. The computer did its job. And the switch did its job. If I come over here, this is 12 volts, and I measure 12 volts, guess what that means? That means this is not a ground potential. That means this computer, something did not go according to plans. Maybe this low pressure switch is open. Maybe this high pressure switch is open in the open state. Maybe never received a request. If you go and you jump the AC low pressure switch and say, you know what I'm going to do? Let me go jump it, right? If it comes on, oh, Easy. It's the low pressure switch is the problem. Well, let's say the AC lower pressure switch is open, meaning instead of here in the yellow, it'll be here. Because it is 5 psi and it's very low and it's supposed to be open. By you tripping this or putting whatever you put, what do you call it, a short across it, now you're actually taking something that's supposed to be open because the pressure is low and you're jumping it. That's not good. If you don't see the damage now, you'll see the damage later on with leaks and bad components. So that's not good. That's why I don't recommend to do so. What do I recommend? Again, I go over here and I will show you in the relay, hopefully when I get enough views, how to measure it over here. 0 volts, I measure 12 volts. Here, 12 volts here, that means 0 current going through here. This is open. What's my next procedure? I want to make sure this is closed. This is 12 volts. 12 volts on this side. If this is open or closed, I'm going to measure this point over here. This is a connector. There's a connector that goes here. On the A terminal is 12 volts all the time. If this is in a closed position, how much should it also be? 12 volts. If this is in an open position, how much should this be? 0 volts. I'm not connected. Right? So this will tell me if this is open or closed. At least I'll know this part of the equation. So therefore, after I went over here and I measured 0 volts, I come over here and I say, let me see if the high pressure switch is working voltage wise, not jumping it, because maybe the high pressure is high and I'm jumping it. I come over here and I measure 12 volts here, 12 volts here. That works. I come over here now. I come over here and I measure. How much should you measure over here if this is connected? 0 volts. Why? It goes to ground. If I measure 0 volts over here, that means it's closed. That's good. That means the pressure is correct. If I go over here and I measure 12 volts over here, right? That means this is open. Right? That means this is open at 12 volts. So therefore, first here, first there, after I did this. These will tell you if it's a computer problem or a pressure switch problem. If you get the wrong voltages, you can always unplug this. If you get 0 volts, fine, it's working. Unplug it. You see terminal A? Unplug it, AA. C2 is the connector. Unplug A. See if it goes up. It should go up to 12 volts because it's not connected to ground. That means this is good. That's the way to measure it. Don't jump anything. It's like a fuses. Anyway, thanks for subscribers. I've been doing this a year and a half. A little more. Thanks to the subscribers, and please, I wish every subscriber would give me 1 view on every video. It will be great, and I want to show you hands-on what I'm talking about, but it requires more viewers. Thank you.